Good morning, students. In the previous class, we have learned about how to solve sums based on algebraic identities. So these are the list of algebraic identities. Okay. In today's class, we will be discussing about factorization. So we will be solving sums based on factorization. So how do you factorize? There are two ways to factorize, either by taking common factor out or by grouping them. So let us see as to what is this by taking common factor. How do you factorize? AB plus AC is given to you. Okay. So AB means A into B. Likewise, AC means A into C. Now you can take A common out from both the terms. If you take A common out from the first term, what will be left out? B alone, right? Then you will have plus. Then from the second term, if you take A, what you will be left out with? C. Am I right? So take out A and then open the bracket, then write B plus C. This is factored. This is how you factorize by taking the common factor out. Okay. Then the next method is by grouping them. Grouping means you group the common terms together. Okay. Now if you see, there are four terms. What are they? A plus B minus PA minus PB. This is the given question. So the first term for me given to me is A. Second term is B. Third term is minus PA. Fourth term is minus PB. If you see, there is no similarity between the first and second term. So let it be as it is. Okay, I am not grouping them, just letting it as it is, be as it is. Then if you look into third and fourth term, there is something common. What? Minus P is common between the third and fourth term. Right? So we can take minus P out. If you take minus P out, you will be left out with plus A plus B. Right? It is A plus B. Am I right or not? Then from the second step, if you look, A plus B is common in both the terms. Like they have just bracketed, right? A plus B minus P into A plus B. If you see, A plus B is common. If it is common, I will take it out and write only once. So I have written A plus B once. Then if I take out A plus B, what will remain? Nothing but 1 will remain, right? 1 into A plus B will again give me A plus B itself. So 1 will remain, minus will remain, P will remain. Why? Because A plus B I have already taken out common. Got it, students? So let us look into the exercise 3.5, question number 1. Factorize the following expression. First subdivision, 2a square plus 4a square b plus 8a square c. Okay. How do we factorize it? If you see carefully, you will be able to see 2a square is common between all the three terms. Now, how do we find out whether 2a square is common or something else is common? You can do it using Hcf method. Got it? You can simply take 2a square, 4a square b and 8a square c. I hope you remember what is HCF, students. Highest common factor. Okay. So if you see, that only 2a square will be common between all the three terms. I have taken 2a square out. If I take, what will my first term become? It will become 1 because I have taken 2a square completely out, right? Then from the second term, if you see, it is 4a square b, out of which if you take 2a square, you will be left out with 2b, right? Because 2a square you have taken out already. Okay. Then plus you have to write as it is, 8a square c. Again, if you take common out, 8a square c, 2a square, if you take common out from that, you will be left out with 4c. Students, if you are not able to understand the meaning of taking common out, basically I am dividing 8a square c by 2a square. Likewise, I have got this. Okay. So I have got my answer, 2a square into 1 plus 2b plus 4c. I cannot further factorize. So I am leaving the expression as it is. Got it, students? Now moving on to the second subdivision. AB minus AC minus MB plus MC. Okay. I cannot take the common factor out for all the four terms. So what will I do? I'll try to group them up. See, first two terms and third term and the fourth term, you can group them up, right? If you see carefully, from the first two terms, A is common. From the third and fourth term, minus M is common. Am I right or not? So what happens? If you take A common out, you will be left out with B minus C. right? Then minus m, if you take out common, you will be left out with again b minus c. Now if you see carefully, you have b minus c common from both the terms, right? You have to write it only once. Please pay attention, only once you're supposed to write. You're not supposed to rewrite b minus c twice. No, not done. Got it? So you have to write b minus c and then you will be left out with a minus m. Got it, students? Okay. Moving on to the next question, number 2. Factorize the following expression. So I will be solving third and fourth subdivision. The rest of the sums are for homework. Okay. How do we solve them? See, we have already studied in the previous class how to solve the sums using algebraic identities, right or not? Okay. So let us see. In the question, we have given x power 5 minus 16x. See, if you take x common out, can you see x common out from both the terms, right? You can see, right? In the first term, you have x power 5. In the second term also, you have 1x. So let us take that x common out first. Okay, if I take that x common out, what will I be left out with? I'll be left out with x power 4 because I have taken already 1x out, and then I'll be left out with minus 16 from the second term. Am I right or not? Okay. Now, if you see this x square minus x power 4 minus 16, do you remember this identity which we studied in the previous class? A square minus b square. How can it otherwise be written as a plus b into a minus b? Am I right or not? Okay. Now take a as x square and b as what? 4. Basically take a as x square and b as 4. And then substitute in this formula. That's it. See, in the question I have one x out, so I have written it as it is. In the bracket what I have written, x power 4 minus 16. That x power 4 minus 16 can otherwise be written as x square the whole square minus 4 square. Am I right or not? Yes. Now this you have to substitute in this given identity. What is the identity? A square minus b square equals to a plus b into a minus b. A minus b. So it is x square plus 4 into x square minus 4. Am I right or not? Now again, if you see, x square minus 4 can otherwise be written as x square minus 2 square. Am I right? Again, the same identity can be used over here. That is a square minus b square identity. That is a plus b into a minus b. Right? So a for me is x and b for me over here is 2. So I have expanded further expansion. I get x into x square plus 4 x plus 2 into x minus 2. Mind you, students, you cannot expand x square plus 4 in the same formula because formula states a square minus b square. We don't have a square plus b square in this formula, right? So you're not supposed to make use of this formula for this plus. Got it, students? Okay. Moving on to the fourth subdivision. What is given to us? M square plus m square plus 1 by m square minus 23. This is the given question. Now, how do I solve this is, okay, let us add plus 2 and minus 2 to this expression. It will not affect my sum at all if I add plus 2 minus 2. Am I right or not? If I simply add plus 2 alone, then it will definitely affect my sum. Got it? If I do something like if I am adding, I have to subtract with the same number. So that's the rule. Okay. So I have added and subtracted with 2. Okay. Plus 2 and minus 2. If I do that plus 2 and minus 2, what will happen to this? Let us see. In the second step, I have written plus 2 minus 2. In the third step, what I have done? I have added the 2 and 23. That is minus 2 and minus 23 will give me minus 25. Right? Okay. Let it be as it is. Now, from the first 3 terms, that is m square plus 1 by m square plus 2, you have, right? That can otherwise be written as in the place of 2, not in the place of 2. In the third term, you can multiply and divide by m. Again, this will not affect my sum. If I simply multiply and forget to divide, then it will affect my sum. But over here, I am multiplying as well as dividing with the same variable. Am I right? So it will not affect my sum at all. So I have multiplied and divided by m. Okay. Now from the first 3 terms, what do I get? I get I can rewrite this in the form of an identity. Which identity do you remember? A plus b, the whole square identity. Got it, students? I can do it in that. So if I applied that identity, I'll get m plus 1 by m the whole square. Got it? Okay. Then what will happen? I have written this as what? Minus 2 minus 20, that is I will get minus 25. So this minus 25 can otherwise be written as 5 square, right? Minus 5 square. This again in turn is an identity. Which identity? A square minus b square identity. That is a plus b into a minus b. Am I right? Or a minus b into a plus b. I can write it however I want. It will not affect my sum. So I have simply expanded the identity. That's it, students. Next sum. Question number 3. Factorize the following expression. First expression, 4x square plus 9y square plus 25z square plus 12xy plus 30yz plus 20xz. Okay. So for this sum, I am going to make use of the identity a square plus b square plus c square plus 2ab plus 2bc plus 2ac equals to a plus b plus c the whole square. Now it is not very much evident to us. We have to find out, as in we have to modify the sum in such a way that it applies, that it corresponds to my given to the identity. Okay, so you have to write 4x square as 2x the whole square. See, 4x square or 2x the whole square are both one and the same. Am I right or not? Yes. Similarly, 9y square and 3y the whole square are also same, right? Then 25z square or 5z the whole square again is the same. 12 can otherwise be written as 2. Okay, if you are not able to do for this 3 terms, you can just apply the identity type. Like see, in the identity what you have just found a to be 2x, right? B to be 3y, C to be 5z. Now in this identity if you apply, you will get 2ab, right? So you have 2 into what is a? 2x. What is b? 3y. C you have written. You can cross check if you want. Multiply, no? 2 into 2 will give me 4. 4 into 3 will give me 12. Yes, I have got 12 xy. Okay, 12 xy. Do you understand? If you are not able to write it like that, you can simply substitute it in with the identity itself. Okay, so it will be easy for you all, so that you don't get confused. Plus again 2bc. So 2 into what is my b? 3y. What is my c? 5z. Plus 2 into a, that is 5z and 2x, right? You can do it in that way. So you have got to write in this identity. If you have something like this, this can otherwise be written as what they have given, a plus b plus c the whole square, it seems. So again a is 2x, b is 3y, c is 5z the whole square. Listen students, in the last class itself I told you all what is the purpose of making use of identity. It is to make the sum much easier for you all. Got it? So you have to be well versed in identities. Again I am telling you, it will not be much evident. It is up to you all to find out as to which identity can be used for the appropriate sum. Okay, moving on to the second subdivision. Okay, what is the question? 25x square plus 4y square plus 9z square minus 20xy plus 12yz minus 30xz. Again, this can be written in this format. Which format? In this identity. Which identity? A square plus b square plus c square plus 2ab plus 2bc plus 2ac equals to a plus b plus c the whole square. Okay, so 25x square can otherwise be written as 5x the whole square. 4y square can be written as 2y the whole square. Similarly, 9z square can be written as 3z the whole square. Am I right or not? Yes, it can be written like that. Then what will happen? Okay, this if you take, you have minus 20xy. Okay, then you have a plus 12yz in the given question. Then you have minus 30xz. What is my formula? I have found a to be 5x, b to be what? 2y and c to be 3z. Am I right or not? But if you see carefully, you have one minus. Where is that minus? That minus applies for b term and the c term. Got it? What is my b term? B term is 2y. So you have to put minus 2y. Similarly, for c term, you have to put minus 3z. Okay, then just merely substitute in the left hand side of the identity. Yes, is it getting satisfied? Am I getting back the question? If I open up the bracket, yes, I am getting. Then I can proceed. As in, I can rewrite this in the RHS part. That is a plus b plus c, the whole square format. So, a is 5x, b is minus 2y, c is minus 3z. Got it, students? Moving on to the next question, number 4. Factorize the following expression. 27x cube minus 8y cube. If you see carefully, 27 is equal to 3 cube and 8 is equal to 2 cube, right? What do I mean by cube? I mean 3 into 3 into 3. 3 multiplied 3 times, not by 3. 3 is multiplied 3 times. Similarly, what do I mean by 2 cube? 2 into 2 into 2. That is 2 is multiplied 3 times. You get my point. So it is multiplied 2 into 2 into 2, like that. So 27x cube can be written as 3x the whole cube minus 2y the whole cube. Am I right or not? Okay. If I can write like that, then I have to make use of this identity. Which identity? A cube minus b cube equals to a minus b into a square plus ab plus b square. Make a note of all these identities in your book, students. All these identities are very important. Okay. So what is my a over here? A is 3x. What is my b? It is 2y. Okay. So a is 3x and b is 2y. I am merely going to substitute in the RHS part, that is the right hand side of the identity I am going to apply. Okay, in the place of a I have put 3x, b as 2y, then again a square, 3x the whole square plus 3x into 2y plus 2y the whole square. Then in the next step, what am I doing? I am merely opening up the bracket, that is 3x the whole square is 9x square, right? Then 3 into 2 is 6, x into y is xy, 2y the whole square is 4y square. Got it, students? Moving on to the next subdivision, number 3. A power 6 minus 64. This is the given question. I do not have any formula for power 6, right? But okay, before proceeding, let us rewrite 64 as 2 power 6. See, if you cross check, you will get 2 power 6 to be 64. Okay, then I don't have, as I told you, I don't have any formula with power 6 as of now, right? Okay, but still, can you make this as a square the whole cube minus 2 square the whole cube? Will it affect my sum? No, right? I will, if I open up the bracket, I will get back a power 6 and 2 power 6, which means I am right. I can proceed. Okay. So again, making use of the same identity, that is x cube minus y cube equals to x minus y plus x square plus xy plus y square. If I make use of this identity, I will be able to factorize it. Got it? What is my x? I have taken a square. What is my y? I have taken it to be 2 square, right? Merely substitute, that is a square minus 2 square into a square the whole square plus a square into 2 square plus 2 square the whole square. Then what are you going to do? See, if you see carefully, again a square minus 2 square is in the format of which form? Is in which format? A square minus b square format. What is the identity? What is the formula? A square minus b square equals to a plus b into a minus b, right? That is a plus 2 into a minus 2. Done with that. Then come to the next bracket. What is that? A square the whole square, which is a power 4 plus a square into 2 square, that is 2 square is 4, right? It will become 4a square. Similarly, 2 square the whole square, which means 2 square is 4, 4 square is 16. Got it, students? Okay. Then what do we do? In the next step, first two brackets we do not touch because it is fully expanded. You cannot do anything beyond that. Over here, what do we do? Okay. We can write this 4a square as 8 minus 4. See, you tell me, what will you get? 8 minus 4, you will get it as 4. Am I right? Will it affect my sum? No. 4 can otherwise be written as 8 minus 4. Just because a square is already there. So, I have to write 4a square can be otherwise written as 8a square minus 4a square. Okay. So, in the next step, what happens? I have to expand what a plus b the whole square format. Okay, I'm going to club up the first three terms, that is a square the whole square plus 4 square plus 8a square. If I club up, I will get a square plus 4 the whole square minus 4a square can otherwise be written as 2a the whole square. Got it? Okay, so that is, as I told you, I have made use of this identity. Then what happens? You can again make use of which identity? A square minus b square identity. A square over here is a square plus 4 and b square over here is 2a. Simply open up the bracket, you will get a square plus 4 plus 2a, then a square plus 4 minus 2a. That's it. You can also rearrange and write. It is the same. Got it, students? You have to be very careful while solving all this. Moving on to the next question, number 5. Factorize the following. First subdivision, x cube plus 8y cube plus 6xy minus 1. This is given to me. See, we already have this identity. A square plus b square plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. If you see, if you look into the question, you do not have any such identity as given in the question. You have to, it is up to you to, make this, make the question into this format. Which format? Into given identity format, so that you will be able to use the RHS part of this. Got it? So, in this sum, A is what? X, B is 2y and C is 1. Okay? So, what happens? First of all, let us take minus common out from the entire question, it seems. Okay, if I take minus out, what will happen? I will get minus x cube minus, the signs will change basically, minus 8y cube minus 6xy plus 1. Got it? Okay. Then what am I doing? I am just rearranging that plus 1 and minus 6xy in the third step. Okay. From the fourth step, what am I doing is, I am rewriting this in this format. Which format? Given the given identity, this is not given to me. I am only assuming the sum to be in this format. Okay. So then I have to cross check, right? So let us first of all try to write the equation in this format, a cube plus b cube plus c cube minus 3abc format. So what happens? I can write minus x cube as minus x the whole cube. Similarly, minus 8y cube as plus into minus 2y the whole cube. Then plus 1 as it is, because even if you write this as 1 cube, it is going to remain 1 only. Right? Then, as I told you, what is A? It is x. What is B? It is 2y. What is C? 1. I have written that format. Yes, it is satisfying. So, I can write this identity in the right hand side format. That is a plus b plus c into a square plus b square minus ab minus bc minus ac format. Got it, students? Then what will happen? As I have written it over here, the minus will remain as it is. So minus of x minus 2y plus 1 into minus x the whole square plus of minus 2y the whole square plus 1 square minus x minus 2y minus of minus 2y into 1 minus 1 into minus x. Okay, as I told you, you have merely substituted. That's it. I have not done much to it. Then what do I do? I open up the bracket. That's it. After opening up the bracket, I get this, what, x square plus 4y square plus 1 minus 2xy plus 2y plus x. Yes. Moving on to the next subdivision, L cube minus 8m cube minus 27n cube minus 18lmn. Again, I am making use of the same formula that as I did in the previous sum. That is a cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. Okay, so let us merely substitute. Put a as L, b as minus 2m, c as minus 3n. Okay, so in this format I have put, that is L cube plus of minus 2m the whole cube plus of minus 3n the whole cube minus 3l into minus 2m into minus 3n. Then what happens in the next step? I substitute in the right hand side of the identity. So I'll get L minus 2m minus 3n into L square plus, what is my B? I have taken B as minus 2m. So I have written down the bracket. Okay, if I read without the bracket, the meaning changes. So within the bracket only I have to write minus 2m the whole square plus minus 3n the whole square minus 1 minus 2m. Then minus of minus 2m into minus 3n minus of minus 3n into L. Then I simply open up the bracket and then I get the answer. Yes, students. Let's do a quick recap. So in today's class we studied about factorization. I told you that we can do factorization by two methods, that is either by taking the common factor out or by grouping them. You yourself will be able to very clearly identify whether you will be able to take the common factor out. When will you take common factor out? When there is a common factor throughout the entire question. Okay, if there is only common factor only between first, second term or third term of and fourth term, if it's something like that, then you will opt second option, that is by grouping. You will group and then you will take the group it in pairs and then you will factorize it. Got it, students? And in most of the sums, what do we make use of? We make use of algebraic identities to factorize. So you have to pay attention to all the algebraic identities. You have to memorize them carefully and then you have to move on to factorization. Got it, students? The homework sums will be sent through Google Classroom. Thank you so much, students.